Mhm. Hello everyone. Today I will be discussing the topic that I chose, usage of AI to decipher ancient texts. Um, so we may continue. First of all, I'd like to briefly discuss our table of contents. So we have introduction, our overview, significance, our target audience, data collection and purposes, advantages and disadvantages, experimental results, statistics, my personal evaluation, my comparison, the pie chart that I made using language models that I downloaded online, so LLMs basically, and then finally saying thanks. So the two papers that I chose that I put in the reference list too is Ancient Egypt Hieroglyphics classification and then Ancient Greek classification of hieroglyphics. So basically they would restore damaged Koine Greek inscriptions using AI and they would decipher it this way. So let's start with our introduction. I will try to keep introduction as brief as possible. So what the papers discussed. The first paper about Egyptian hieroglyphics was about using a deep learning approach to the classification of ancient Egyptian hieroglyphics, a crucial task in Egyptology. The authors introduced their own custom LLM AI model called GlyphNet that was developed specifically to decipher damaged ancient Egyptian hieroglyphics and to basically translate it in real time to English. By applying these machine learning strategies, the paper seeks to enhance the study of ancient Egyptian texts by particularly making it more efficient and scalable for other researchers. The other one was about Koine Greek inscriptions, where another AI called Ithaka, I'm not sure how it's pronounced, was used. It's another deep learning model that was designed to assist in deciphering ruined texts which were partially damaged, so it was not readable even if you knew ancient Greek. And therefore, AI was basically used to predict with high accuracy what the text likely said. So it would restore the texts that were actually absent by predicting or trying to see from the crevices of ruined stones whether it's likely to be, let's say, letter lambda instead of letter beta or alpha. So this was our introduction. Now we'll continue with overview, what I think. So first I'll start with overview of the Egyptian study. Overview of this study mainly, I would say that it mainly focused on more humanitarian stuff. So there were not a lot of math, and the language model used there wasn't as math-based. Rather, it tried to decipher it via images. It makes more sense given that ancient Egyptian hieroglyphics are generally pictures, so real-time depictions of, for instance, birds or humans or everyday objects like knives. So these were mainly 75 to 50 pixel grayscale images, and they could go up to 100 by 100 pixels. However, the AI wouldn't support anything more than that. The AI was trained on about 4,500 images, and it had the error rate of plus minus 0.5%, which is very accurate actually. And it mainly used a CNN architecture that was tested on ResNet 50, Inception v3, and Exception. So that was basically it. And now when we talk about the model of the architecture, so researchers used all publicly available ruined ancient Egyptian papyruses, for example, this one, even though it looks like a stone. Now, our second overview of the Greek study. The Greek study was more based on maths by solving differential equations and sums, mathematical sums. So Ithaca uses a transformer architecture with character embeddings, word embeddings, and positional embeddings. The key findings there were that it could successfully decipher with about 82% accuracy the texts that it had, which had missing parts. For example, let's say a sentence. an apple is, and then the last sentence is missing, or only the first letter, let's say G is present, it would predict that this word was likely green. So an apple is green. So it's researchers without much effort to understand what the ruined Greek text said. Now, significance of the topic. I think that the topic is significant, and its significance lies in its potential to revolutionize the study of ancient texts. So here I will rather discuss both of them together since they covered similar domains, so their significance would be pretty much similar to me. So I believe that this helped to revolutionize the study of ancient texts by automating the restoration and attribution processes, enhancing the efficiency and accuracy of historical research while facilitating collaboration between machine learning and human experiences. So researchers have more time to explore other domains of their study fields rather than trying to decipher, which takes quite a lot of time, months to years. So this made their work much easier. Now, number 5, audience purpose and data collection. So these are 3 separate topics which I decided to gather all together. So these are the 2 papers which I mainly drew from. And since the topics discussed were quite similar, the audiences were also similar to each other. About the ancient Egyptian hieroglyphics, the audience was mainly for researchers and practitioners in Egyptology. This is a new field which was started after the discovery of the Rosetta Stone. The purpose was mainly to develop a deep learning based method for classifying ancient Egyptian hieroglyphics, so to understand how we can decipher them more easily. And the methods for data collection were mainly 2 databases that the researchers called D1 and D2. D1 used 172 different images, and D2 is 1,300 images, or up to 100 by 100 pixels. And when it comes to the other one about Greek inscriptions, the audience was mainly about historians, epigraphers, and even researchers, new non-PhD researchers in the field. The purpose was to create, again, another deep learning machine, Ithaca, which can actually be used in other fields too, to decipher even relatively newer texts. And I believe that I've read a commentary by the researcher, and they told that their other purpose was actually that they can develop this model into another model that can be used to kind of decipher texts that are barely readable due to some reasons, even though they are quite, let's say, modern. And the data collection method was pretty much similar. They drew from about 4,000 images and real inscriptions. So now we may continue with our pros and cons. So strengths and weaknesses. I made this chart so that we can easily see it. So first of all, the positive sides for Egyptian hieroglyphic research was that it introduced deep learning for hieroglyphic classification, which was new in the field in Egyptology, actually. It had custom architecture and used data augmentation. It also was effective for use of transfer learning for improved performance. So it had very high precision, in other words. However, it had some negative sides, like class imbalance, which made it unpredictable whether the error margin will be larger or smaller just because of a few pixels that were off in the images. Other than that, it had limited data set. Usually for a good LLM model, AI, you would need about at least 4,000 to 5,000. However, this one only used 1,300 in one of their sources. And the other drawback was high variability in precision. So sometimes it would be very accurate at predicting what text said, sometimes not. When it comes to Ithaca for the Greek study, the positive sides were that it mainly talked about hybrid human-machine interaction, how humans and AI can coexist, like work together so that the research would be much faster. So it wouldn't take months, but actually days to perform. Other than that, it tackled multiple tasks. So it will not only to decipher, but it also helped to restore their geographical location, so where they actually came from, and using carbon-14 dating, how old they were. It also was groundbreaking in its own field for Greek research, mainly for biblical studies. But however, it also had its drawbacks like circularity in data, since they actually fed the same database to the LLM multiple times, which made there is something called heat scale, so temperature for LLMs. It made its temperature quite high, which means that the predictions made by the LLM would be the same every single time, which you don't really want to happen. So you want it to happen about 70% of the time, but here it was, I think, about 90. And also had, it was limited to epigraphic fields, so it was not tested on other means, so that we could see whether we can expand it into other fields. It also had some ethical concerns, which I will not dive into deeply, but I will just mention superficially that it relied on machine-generated hypothesis, which doesn't have its own peer review. However, the research itself is peer-reviewed, so it works. Now, I will talk about the experimental results, methodology, and hypothesis. So, this is their main achievement for Greek tablets, which showed high accuracy, um, increased precision, and it had its own comparison with pre-trained LLMs, which were used, however, weren't as successful for this field. So, for instance, in the example of Greek tablets, they used something called transfer learning, which used pre-trained models like ResNet or Inception V3 in specific scenarios, and it actually helped to boost the accuracy rate of the LLM. Other than that, its data augmentation impact was quite high. So the application of data augmentation techniques led to an expanded training of data set, improving the model's ability to generalize basically and prevent overfitting. So overfitting is another term where LLMs would basically even after receiving feedback answer to the same question wrong multiple times in a row. So for instance, if the LLM says that 2 plus 2 is 5 and you correct it so that it's 4, and if it again says that it's 5, then it would basically be an issue of overfitting. Now, when it comes to Egyptian papyrus hieroglyphics, the things which I wanted to summarize mainly was that it had a restoration interface. It had a very high model accuracy, and again, its data augmentation was decent. So, the model correctly identified the regional and origin of the inscription. So other than actually deciphering it, it could tell whether it comes from, let's say, upper banks of the Nile, or whether it's somewhere in the middle or actually below towards like Sudan, even not in Egypt. Other than that, it had unlike traditional models, Ithaca, like it had interpretable output. So you could actually, it would provide multiple meanings to what the text could actually mean. So researchers had more insights. Now, I would talk about statistics and data, which I completely took from the papers. So this is about Egyptian hieroglyphics. So first of all, let's talk about A, B, C, and D on the left. These were some of the examples that the researchers mentioned, how the LLM model could actually basically decipher and predict the upcoming, let's say, sentences and words used here. So, for example, here in A and B, it is the actual thing that were set in the papyrus sheets, and C and D were the predicted outcomes drawn from A and B. And since it was believed to be very precise, researchers concluded that the actual decipherings and interpretations were right. In the middle, we see something else. It's more about LLMs. So basically, here we see that dropout rate is 0.15. It's actually with percent. So it means that the LLM was quite accurate, and its global average pooling data set was also quite large, so it was expected. In figure 13, we see that the researchers actually used multiple LLMs before finally ending up using their Inception v3 model, which had a nice balance of runtime to accuracy. And in these tables below, we can basically see their accuracy, precision, and recall. And we can see that Inception v3 actually succeeded the most in their research, so they picked that one. Now, when it comes to ancient Greek inscriptions, um, so the chart below, there where we see dashed lines, describes cases where the language model had high accuracy of predicting what the missing text is, which is highlighted in green color. However, 2 and 3 means that it had lower percentages. So basically, the LLM model would provide a few options with likelihood rates, and then researchers can choose which one the ruined text likely said. On the left hand corner, we see actually a map, and this was mainly uh, used to show the probability of the amount of correct predictions by the LLM, and so basically the ratio of correct predictions by the LLM to where the inscriptions came from, since they use different dialects of Greek. So as we see, the ones from Ionia, for example, were much easier to decipher than the ones from, let's say, Chios or Mysia. The other graph shows it's basically the Ithaca models, like success over time, different versions of Ithaca and how they performed. And the research paper discusses its latest version, which was peer-reviewed as well. Now, I would like to talk about my personal evaluation and conclusions. So, firstly, what I think about this research is that, as we can see on the left, the Egyptian hieroglyphics research was more based on images and how the AI could basically predict which image stood for which, for example, consonant in some cases and which word in other cases, depending on how old the inscriptions were. However, we can see that this was not the case for Greek ones, since they used quite a lot of math there. For example, to calculate the accuracy, they divided the sum of accuracy rates by the length of the inscription, which I really don't understand why it was used. However, it was. Sorry for this. Um, and they also had some variable that they assigned themselves called CER that depended on the length. And by using this, they could actually estimate how successful their upcoming prediction would be. Other than that, I want to mention that the reliance on data augmentation techniques actually may introduce some level of bias or inconsistency. So even though I will not be talking about the researcher's own bias, as my own criticism of these papers that the researchers also acknowledged, the papers were generally biased. So they included quite a lot of data, which could be biased because the same data was fed to LLMs multiple times due to lack of publicly available images, inscriptions, and data that the researchers could use. However, the rate of it being highly biased is quite low, and therefore we could consider that they were quite successful. Now, finally, I will talk about my final comparison. So here I made a chart and listed some of the things that I think are important to consider. So research focus. While our first paper about Egypt focused on deep learning, I think focused on other aspects of learning, like addressing multiple tasks, which the first paper lacked. Second of all, the data used were quite different. While the first paper only used a small data set, the second one used a much larger data set with IPHI corpus of ancient inscriptions. This is, I think, a large library for ancient Greek inscriptions used by the researchers. Data augmentation was quite um, high quality for both of them. For example, about the second paper, I think I can mention that it used text clipping, masking, and word deletion, which was really useful in the research. And model architecture used for the first one was their own LLM called GlyphNet, and the second one was Ithaca. So now I want to discuss my own pie chart that I made using the data from there about the distribution of the importance of topics. So there, I downloaded Pinocchio, which is an AI library app, and I used my the LLMs there, which I trained myself to get this raw data. So here we can see that while impact and contributions by this paper were the most significant, human-machine collaboration was quite lacking, especially for the first one about Egyptian hieroglyphic research. And the same can be said about ethical considerations, which were a problem. So by this, I would like to conclude my presentation. Thanks. Deniz, ne kadar çok